Okay, so what we have here is a helium neon laser that is set up to reflect off of two tuning forks and then project onto a wall. And you can see it on the wall right there. So what we have is a helium neon laser here. You could do this with a diode laser. It doesn't, which is not really a laser, but you could do it with a diode quote laser pointer. But you know, got to get the full effect with a helium neon gas laser. We have two tuning forks. Here's one that's mounted vertically, and then I have a reflective surface here. I have a glove on because I keep flicking these tuning forks and my thumb is wearing out, not for any other safety reason. So we're bouncing off this first tuning fork, off of the second tuning fork, which is an octave higher. It's twice the frequency of the first tuning fork. It's just all I happen to have. I ordered some more, but that's what I have. So it bounces off the first tuning fork, off the second tuning fork. They are perpendicular to each other, almost, and then onto the wall. So we are going to set off this first tuning fork that is vertical. So I'm going to do that now. To set off the first tuning fork, we now have a line on the wall instead of a dot. You can see the line is slowly shrinking as the tuning fork is vibrating less and less and less. Now, the second thing we're going to do is vibrate. We're going to set off the only the other tuning fork, the horizontal tuning fork, so we can see what we see on the wall just with that. Alright, so here we go. We have a line going horizontally now. The line's going horizontal, and it's shrinking and shrinking and shrinking and shrinking as the tuning fork loses its energy. And the next thing we're going to do is we're going to do both of them, which is going to be a trick for me to get this on camera since I'm doing this by myself. But it's important to know, first of all, that the tuning forks are perpendicular to each other. And it's also important to know that the frequency of the horizontal one is twice the frequency of the vertical one, because that determines what we get on the wall. And I don't want to ruin the surprise because it's pretty cool. So I'm going to see if I can do this really quickly. Here we go. There we go. That's called a Lissajous figure. And this is not the first mode of the Lissajous figure. I need to get two tuning forks that are the same frequency. Having two at the same frequency will actually get us a circle or an oval that goes through its different phases. We're basically plotting one sine wave on the x-axis and another sine wave on the y-axis. You can think of the unit circle when we're talking about that. Okay, what we're going to do next is we're going to pull out the horizontal tuning fork. I'm not going to use that. We're going to use only the vertical tuning fork, and then we have this hexagon here. We've got a mirror on each side of the hexagon, and you can see that the laser is reflecting off of the tuning fork onto the hexagon, and you can see that it's on the wall here. And I'm going to turn this thing on. This is motorized. Turn this thing on. There we go, it's moving. And then we'll look on the wall and see what we get. And we can see that we get sort of a line here. And so basically we're you can imagine that we're plotting this non-vibrating dot on the x-axis kind of being time. We're moving it through space, across a distance. So you can either think of it as a distance you're moving across or a time. So now we're going to vibrate this, set off this tuning fork and see what we get. And here we go. We get a handy dandy little sine wave here. Pretty cool. Let's do that one more time. There we go. There it is. The only reason why it's moving up and down is because my little mirrored figure is a little bit lopsided. But basically you can see that the line, the dot that's moving up and down in a line is also being moved across, and then you're able to see the oscillation of this tuning fork a lot better. And that's pretty much it.